Simon's program on federated and collaborative learning. My name is Virginia Smith. I'm a professor at Carnegie Mellon University, and I'm one of the program co-organizers, along with John Ducci, Nika Hajjatab, Peter Kairos, and Nadi Srebro, and Kunal Talwar. So very, very excited to be one of the organizers of this. This has been something that we have been thinking about for a while now, so it's quite exciting to see it come to fruition. Just to give you a little bit of background detail on the origin story of this program, we initially sort of conceived of this idea several years ago, and then we had a workshop hosted at Simon's in the meantime to kind of gather consensus from folks in the community, think a little bit about what the program would look like, what these workshops might be, what are some of the big questions we might be trying to answer through the program. So you'll see here Katrina, who we'll hear from later this week. She'll be giving the RMK lecture later this week. Kunal, sitting in a similar position to before. So this is from the workshop. And now we're here in spring 2026 at the start of this program. And the reason I wanted to bring this up is that, as you know, a lot has transpired since 2022 in the field of not just federated learning, but AI more generally. So one thing we really want to do as part of this program is to understand what are some of the big open questions in federated and collaborative learning, especially in light of all of the advancements that have happened in AI. Okay, so even though a lot has changed, I think some fundamental questions obviously remain the same, right? So what is a big motivation for federated and collaborative learning? It's that AI relies on data, right? So you can scrape some data from the internet, but often for our applications, we need access to more data, right? And this data isn't coming often just from a single person, a single patient, a single sensor. It's coming from many, many entities, right? So multiple users or clients, multiple organizations, possibly multiple sensors. And we need to think about how to access and incorporate all of this data in our AI systems effectively and in a way that puts these clients often at the forefront. Okay, so thinking historically about some applications of federated and collaborative learning that you might have heard of, this has been a popular approach for learning across distributed networks, like across multiple hospitals. So learning models, for example, for tumor detection without sharing raw patient data. There's obviously been a lot of publicity around applications in the mobile context. So for example, learning next word predictors on mobile keyboards without collecting raw text. But a lot has changed from 2020, I think, in terms of these two canonical applications. So there's been more and more use cases that have emerged around federated and collaborative learning, and we're very excited to hear about some of those today. So in particular, this is a slide that I made back in 2020 when we were talking about federated learning, and maybe thinking about federated learning as just machine learning at the edge, right? And there were a number of challenges that existed when you were performing machine learning at the edge. So you had issues with communication, privacy, heterogeneity of the data and of the systems. These are obviously still concerns that we're going to be talking about. But since then, there's been some evolution on the definition and the applications that exist around federated and collaborative learning. So this is a definition proposed in this recent work, looking at federated learning in practice, reflections, and projections. And I think this does a nice job of encapsulating some of the changes that we've seen in the definition of federated learning. And the key thing here being that federated learning is really concerned with building a system that puts clients at the forefront. So it enables clients to maintain control over their data, to set workloads allowed to access their data. It allows for anonymization properties of those workloads. But crucially, we're not thinking about this data just as one monolith, but as coming from a set of partitioned clients or organizations which themselves have control over their data. Okay? So this changes various things. It changes how we process the data. It changes the models that we decide to use. It also brings up a lot of interesting and important questions around things like trust and incentives, control, agency, incentives. So these are all things that we're going to be thinking about as part of the program and in the boot camp this week. Okay, there's also, since 2020, been this emergence of this new paradigm within AI of pre-trained or foundation models. So I think that there are some important questions that we'll be talking about today around how this changes the landscape in federated learning. I think that there's two key ways that we'll see this has changed some things. One is that maybe instead of just thinking about training as being the only workload for federated learning, now we're also thinking about things like post-training, inference, and evaluation in a federated setting. We're thinking about things like how to ensure trustworthy behavior even when we're starting by fine-tuning a foundation model as opposed to training from scratch. And this has also led to the rise of new models of privacy and safety and security that we have to enable in federated settings. What you're also seeing, which I think is interesting, is that the ideas that have existed in the federated learning literature are also useful to improve the development and design of foundation models. And some of this transfer we'll talk about in the bootcamp this week is because some of the key challenges in federated learning are also useful for just building massive models, right? So decentralized training of foundation models, some of the techniques here in distributed optimization from the federated setting are also very useful for thinking about training massive networks, even in a data center scenario. Okay? In federated settings, one of the key challenges here is thinking about how to incorporate heterogeneous sources of data. This is also very useful for building these foundation models where you have to build these massive data sets. Okay? Collaboratively learning these models and, of course, thinking about scalable techniques for trustworthy machine learning. So thinking about some of the techniques that have been developed around privacy and security in the federated setting and applying those to the development of foundation models. Okay, but I think there's also a bigger idea here that we really want to get at with this program. And this is why we have made the name of the program a little bit longer than maybe is desired. So the program is not just about maybe this historical application of federated learning, but about this broader goal of collaborative learning. Whether you want to call this federated learning or this maybe more broad term, where the goal is to think about learning across multiple sources, maybe with multiple stakeholders. And here, again, we're really trying to think about these client-centric perspectives. So how to incentivize participation in these collaborative learning processes, how to develop more trustworthy learning schemes, and effectively model multiple heterogeneous sources. All right, so how does federated and collaborative learning differ from things that you might have heard of before? The key way that we're defining this, that might be different than something like traditional distributed learning or data center-centric learning, is that we're really thinking about these client-first perspectives on distributed learning. So these distributed entities might represent clients, agents, groups, organizations that are trying to collaboratively learn, but might have variability in terms of their data. So there might be heterogeneity in the data, in terms of the resources, also in terms of their expectations and their preferences and their risk portfolios. Okay, another thing that really defines this field is that progress in federated and collaborative learning has really been informed by real systems, real deployments. And this is something that we're hoping to incorporate in the program as well, with a lot of exciting involvement from industry partners, right? So we're thinking often, from a research side about how to define and develop new methods with these client-first perspectives in mind, but we often also have real system constraints to deal with. So we might be thinking about things like, does the method we're developing support partial client participation while we're thinking of a distributed optimization procedure? Would this satisfy HIPAA regulations, right? So there might be some legal constraints that we have to abide by. How would this work with secure aggregation? What if memory was limited to 2 gigabytes per device? So often the methods that we're developing are constrained by these real-world systems and deployments. Okay, and obviously this is a field that has grown in concert with other areas that have developed over the last several years within computer science and machine learning and AI. So technological advancements in hardware and software have made it feasible to store and train models at the edge to perform this distributed computation. There have been advancements in machine learning and AI that are also being incorporated in our federated and collaborative learning procedures. And what we're seeing in particular is that safety and trust is a major topic of interest, obviously, within AI, but also this is something that really takes center stage in federated and collaborative learning. So this is an area that is drawn heavily from the safety community within AI, but also is itself driving advancements in these areas of privacy and security and safety. Why Simons? Why are we having a Simons program? I think this is worth answering before we start this program. So despite a lot of interest and excitement and deployments of federated and collaborative learning in practice, there's still a need for this sort of foundational science. So a better understanding of the fundamental questions that remain. It's also very useful to think about developing unified theory and methodology for this area. So a consistent set of definitions, assumptions, techniques for federated and collaborative learning that do reflect these real-world deployments that we've seen. Okay, and finally, a big goal of the program, and one reason I'm really excited you all are here today, is to foster community within this area and to gather a lot of interdisciplinary perspectives. So federated and collaborative learning draws on really diverse communities. You have folks from machine learning, AI, statistics, optimization, privacy, security, econ, distributed systems, and it really spans industry and academia. So we're excited to bring together this diverse group of voices and to make some progress in this field. Okay, in terms of directions of interest, kind of, mirroring what we have in the workshops that we'll see in the program. Some of the areas that we're quite excited about, and this is by no means an exhaustive list, are thinking about how to more effectively learn from heterogeneous sources. So can we, in particular, more clearly define what this notion of heterogeneity might actually mean? Can we develop some rigorous definitions of heterogeneity? Can we then use that to inform the development of more effective methods for modeling and learning from heterogeneous sources? In terms of trust, can we think about how to develop theoretically strong, principled approaches for trust that also don't make us sacrifice things like accuracy, efficiency, or usability? So can we develop, extend, analyze principled approaches from private, secure, safe AI that can be effectively used in these decentralized learning systems? Okay, and lastly, in terms of agency, again, one of the ways that we've been thinking about federated and collaborative learning is by putting forth these client-first perspectives. So taking this to the natural extreme then, we might think about how do we actually get people to be involved in this process to start with. So what kind of controls might a person have over their participation, over the guarantees that we provide them when participating in this process? Can we capture more granular metrics on client-level performance? So really thinking about this agent-level or client-level perspective within collaborative learning. Okay. I'm not going to go over these in detail. This is, again, not an exhaustive list, but just some thoughts here on some of the directions that we're hoping to look at within these various areas. Okay, so this will be facilitated by, actually what you'll see here is some brainstorming from this morning around some ongoing activities throughout the entire semester. So weekly reading groups, brainstorming sessions, seminar series, but also crucially through a number of workshops. So we have the boot camp workshop this week, where we're thinking about, what are the key goals in federated learning? How has federated learning changed over the last several years? And also giving tutorials on existing approaches for modeling, optimization, privacy and security, and game theoretic perspectives, with an emphasis on really understanding the constraints of real-world deployments, especially modern applications of federated and collaborative learning, and ones that we hope to exist in the near future. Then we'll have a workshop on learning from heterogeneous sources in February. In March, we'll have one on trust. And in April, we'll have a workshop on this last area of agency and collaborative learning. As I mentioned, there will also be a number of activities. We'd love for you all to be involved in these activities throughout the program if you're here. So we'll have reading groups, seminars, working groups, and workshop clusters. We hope to have some reverse site visits to industry labs in the area. And there will also be a number of social activities associated with the program. We have a really great set of participants this semester. So we have 7 fellows. Maybe you all could just stand up if you're here, if you're one of the fellows. Just really quickly. Yeah, awesome. Do you want to just introduce yourselves really quickly? Just people know you? Yeah.
Hi, my name is Mati. I'm from TTI. I work on this aspect of privacy and machine learning. I'm really excited to be here to work on these topics.
Cool.
I'm Kshitij. I'm at Yale. I work on various aspects of heterogeneity, optimization, connections between personalization and privacy. I'm excited to be here as well.
Hi everyone, I'm Chabi. I'm from CMU. I am Virginia's postdoc, and I work on various aspects of privacy, safety, and security, AI in general. Happy to be here. Thank you.
All right. We also have a number of long-term visitors. I'm not going to make all the long-term visitors stand up because it's a lot of people. But yeah, I just wanted to bring up this list because as you'll see, it represents a lot of folks from both industry and academia who have committed to being here for a large period of time. So really excited to have everyone involved and here this semester. I also wanted to point out that so Natty made this slide, and I appreciate his hard work in doing this. This is probably not necessarily a perfect encapsulation of where everyone fits in these spheres, but the point here is to point out that our set of long-term visitors and fellows represents a very diverse background in terms of areas they've worked in. From optimization, statistics, learning theory, privacy, crypto, thinking about core AI, ML models and methodology, game theory, fairness, econ. So really excited to be thinking about all of the diverse perspectives and problems that sit at this intersection. All right, just a couple logistics, and then we'll get started. So I wanted to go over quickly the agenda for the boot camp this week. So today, we're very fortunate to have a set of short talks and then a panel. And this should be updated. Unfortunately, Zio came from the East Coast and was one of the unfortunate people whose flights were canceled yesterday. So, but we have Chester here, who is here. So we're very fortunate to have Chester stepping in from NVIDIA. So we'll be learning from them about what are some modern applications of federated and collaborative learning, and in particular, what sort of challenges exist in light of the developments around foundation models and AI in the last several years. Okay. Tomorrow, we'll have a focus on optimization. So I saw Peter here. So Peter will be giving some tutorials on federated optimization. And then we'll hear from Keith at Google a little bit about this transfer in the other direction, about how federated optimization has been useful also for training large language models. On Wednesday, we'll be thinking about privacy and security. So we have some tutorials on privacy and a tutorial on security as well. So this will be a really exciting day. And then on Thursday, we're going to think about this agency side of things. So thinking about incentives for collaborative learning and data sharing. We'll have some tutorials on this topic. And we'll have Katrina here giving the RMK Distinguished Lecture. So please make sure, if you're able to come and hear Katrina's talk. It's going to be great on Thursday afternoon. OK, and then Friday, we're going to end things off by being a little bit more speculative about where the field is going. So we'll have some talks on very recent work from some folks working in policy and privacy and security. And we'll also have a panel from, really another really fantastic set of panelists working in this space. OK, and one thing I wanted to mention before I forget is that we'll also have a reception at the end of the day today. So if you can stick around, I'd love to chat with everyone at 4 today. So there'll be some snacks, and we'll have some time to hang out at 4. OK. So thank you all. Thanks for being here. Thank you also for giving me the opportunity to leave Pittsburgh at this particular time. I think we've gotten more than a foot of snow since I left on Sunday. So really, really happy to be here. I also wanted to thank the Simons leadership who has been working with us for the last several years. So we've had the great opportunity to work with many different folks on the leadership team, Sandy, Venkat, Sampath. So I wanted to thank everyone, and I wanted to especially thank all of the Simons staff who really makes this possible. Yes, we've been exchanging a tremendous number of emails with all of these folks. I'm sure that you all have as well. I just wanted to call out Carolyn and Atia and Ashley have been doing a lot of work, especially in the last few weeks, to help to get this program up and running. Any questions before we get started? Cool. Okay. All right, great. Are you okay to get set up? Okay, it might take a little while to shuffle laptops here, so it'll probably be good to get started. Should I move this